outstanding research, and remarkable products as its contribution to environment and global community. This study program is accredited A from the National Accreditation Board and AUNQA certified for its curriculum. Teaching and learning processes, research and community service have been equipped with various adequate facilities and laboratories. There are 6 laboratories: Integrated Manufacturing System Laboratory, Organizational Innovation and Development Laboratory, Enterprise Resource Planning Laboratory, Work System Design and Ergonomics Laboratory, Data Mining Laboratory, Modeling and Industrial Simulation Laboratory. These laboratories provide students with skills and specialties in product planning and control, as well as production floor management, designing, producing, assembling products, calculating inventory and the number of workers, scheduling, implementing product control, and others. This laboratory focuses on areas of industrial systems innovation and management, such as corporate design analysis, organizational development, marketing system design, and business feasibility study. This laboratory provides skills and specialties about enterprise resource planning. The learning process is supported by the SAP system and has been a part of the SAP University Alliance since 2005. The SAP University Alliance provides opportunities for students to access learning materials, participate in SAP academic forums, and certification of participation that is recognized nationally and internationally. This laboratory provides skills and specialization in the application of work system design application concepts in order to achieve a certain level of productivity, ergonomics, and aspects that influence it, especially psychological and environmental aspects. The laboratory focuses on analyzing and designing a work system and/or work tool to be ergonomic, safe, comfortable, and healthy. This laboratory provides skills on the use of various methods of multiple criteria decision-making, data mining, and statistics to solve problems in the industrial world. Modeling and Industrial Simulation Laboratory provides skills and understanding of the definition of models, types of models, to create simulation based on real systems. The International Program of Industrial Engineering has maintained and expanded the international collaboration as the effort for the global acknowledgement to provide students with global experiences, exposures, and mobility. The program has also worked with big companies in Indonesia and abroad. Students are also accommodated with international certification to develop student skills to achieve designated expertise. International program exposes students with international experience, culture, and environment as a part of global community. As a sustained effort to sharpen students' capability in certain expertise, the internship is represented as the program that could fulfill the curiosity of a real-life working environment. Community of international students is established to encourage students with soft skills, organization, and teamwork activities. All activities in the international program are beautifully framed under the noble Islamic values with the ultimate guidance of Al-Quran and Hadith.
International Program Industrial Engineering.
Be smart,
be agile,
and be global.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good morning and welcome to Sustainable Product and Supply Chain for the Circular Economy webinar. The honorable to the speakers who have attended this webinar, Prof. Dr. Zuraidah, Head of Center of Automotive Research, Faculty of Engineering and Built Environment, University Kebangsaan Malaysia. Mr. Dr. Taufik Imawan STMM, as the Secretary of Department of Industrial Engineering in University Islam Indonesia. Ms. Dr. Engineering Melinda Fitriani Nur Makfiro, STMBA, as our moderator for today's webinar, as well as all participants in this session. First of all, let's pray to Allah Subhanahu wa Ta'ala, the God of the world, the Master and Creator in this universe, so we can meet and gather in this webinar with a good condition and situation. Secondly, don't forget to leave salawat and salam to our Prophet Muhammad SAW, who has brought us from Jahiliyah era to Islamiyah era. To shorten the time, please introduce myself. My name is Kinan Wiraprasta, a student on the Industrial Engineering International Program as the Master of Ceremony in this morning. On this special webinar, we will have a several agenda as follows: opening, Holy Quran recitation, Indonesian National Anthem Indonesia Raya and Hymne UII playback, opening speech, the main session, quiz, Q&A, and closing. First, let's open this webinar by reciting Basmalah together. Bismillahirrahmanirrahim. Hopefully, today's sustainable product and supply chain for the circular economy webinar can run smoothly. The second agenda is Holy Quran recitation, which will be recited by Muhammad Osa Rosanto. To Muhammad Osa Rosanto, time is yours.
Thank you for Mr. Kinan. Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فاذكروني أذكركم واشكروا لي ولا تكفرون يا أيها الذين آمنوا استعينوا بالصبر والصلاة إن الله مع الصابرين ولا تقولوا لمن يقتل في سبيل الله أموات بل أحياء ولكن لا تشعرون ولنبلونكم بشيء من الخوف والجوع ونقص من الأموال والأنفس والثمرات وبشر الصابرين صدق الله العظيم. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. The third agenda is Indonesian National Anthem, Indonesia Raya, and Hymne UII playback. We ask all of you to join us to sing the Indonesian National Anthem and Hymne UII together. And the next agenda is an opening speech that will be presented by Mr. Dr. Taufik Imawan, STMM, as the Secretary of the Department of Industrial Engineering in University Islam Indonesia. For Mr. Taufik, time is yours. Sorry, Mr. Taufik. Sorry bothering you. Can you please unmute first so we can hear your voice? Thank you.
Okay. Bismillah. Good morning, all. The respectful Prof. Zuraida Abdul Wahab, the teaching Jewish professor of today's short course. The respectful Mrs. Ira Promasanti Rahmadewi, the Secretary of International Undergraduate Program in Industrial Engineering, distinguished participants and college. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for having me here. It is a pleasure to be able to attend and open the opening ceremony of a short course, Sustainability Product and Supply Chain for the Circular Economy. This event is part of short course series held by International Undergraduate Program in Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia, in collaboration with University Kebangsaan Malaysia. Considering the rapid of future global competition and short product life cycle, the acceleration of product launching has become a must. And one of the determinants for dominant is designed to enter the global market shortly with improving resource efficiency. This today's short course highlighting the theme sustainable product and supply chain for the circular economy is expected to be able to share a new insight, give new experience, and foster fresh ideas, especially in this challenging time. This short course aims to contribute to intellectual development as an introduction to pushing the supply chain sustainability, aim to eliminating waste and continual use of resource for business and the world as a whole. It is also different the transformation from make, use, dispose to make, use, recover, reduce, and reclaim. This activity aligns with one of our objectives to nurture extensive study to deepen study knowledge, skill, and ideas, and to pursue excellence in all of our endeavors. It is one of our responsibility to deliver and provide benefit not only to our students, but also to other students and communities around the globe to be ready to contribute globally. Hopefully, this short course held by International Undergraduate Program in Industrial Engineering will be beneficial to all. Together, let us accelerate the exchange of knowledge and scale up good practice to provide us with the huge opportunity to borderless and wider collaboration. Lastly, I sincerely thanks and acknowledge every one of you who extended help by us for making this event a grand success. Thank you very much for your participation, and I wish you all a good health and blessed today. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Taufik. And before further discussion about sustainable product and supply chain for the circular economy webinar, let me introduce you to our moderator for today's webinar. She is Dr. Engineering Melinda Fitriani Nurmakfiro, ST MBA, Education, Tokyo Institute of Technology, Japan, degree Doctor of Engineering, majoring Global Engineering for Development, Environment, and Society. National Taiwan University of Science and Technology, Taiwan, degree Magister or MBA, majoring Industrial Management. Universitas Gajah Mada Indonesia, degree Bachelor of Engineering, majoring Industrial Engineering. Research interests, global supply chain management, humanitarian logistics, sustainable transportation, optimization, and meta-heuristic. And for the next session, that will be moderated by Miss Melinda, and it will be more exciting. And therefore, I apologize if there are any mistake. See you guys on the next agenda. Wassalamualaikum warahmatullahi wabarakatuh. And Miss Melinda, time is yours.
For introducing me. So we would like to convey our gratitude to Professor Zuraida for her willingness basically to share her knowledge through this webinar series. And it is such an honor to be a moderator for today's webinar event. And for your information, this webinar series will be held for today, so today's and tomorrow. And as Kinan already introduced at the beginning, the topic will focusing on the sustainable product and supply chain for the circular economy. So I think some of you might find it quite interesting because the supply chain sustainability itself currently is increasingly important for the future business, for industry, and the world as a whole. And as the United Nations has outlined about SDGs, the Sustainable Development Goals, one of these it's actually require the global supply chain, as they also need to ensure that companies or industries can examine how their business can actually introduce this SDGs concept to improve the sustainability practice. While at the same time, the circular economy system actually can help and have this concept of not to just reuse, but also like sharing, repairing, refurbishment, remanufacturing if possible, and also recycling, basically to create a closed loop system, and as we can minimize and reduce waste, pollution, and also carbon emissions. And the decision to reuse or refurbish, remanufacture, recycles will goes along the way, basically to improve the supply chain, and also needs to be implemented on how we actually develop the product, and then we can build these circular economy systems nicely. However, in fact, to truly build this circular supply chain, circular economies, a lot of parties, companies, industries, probably academia needs to make the commitment to do that, because nothing is going to change or otherwise. And so today's Professor Zuraida will give her knowledge regarding that. And probably I will introduce Professor Zuraida first before giving the time to her. So Professor Zuraida Wahab is currently a professor at the Department of Mechanical and Manufacturing Engineering in the Faculty of Engineering and Built Environment, University Kebangsaan Malaysia. And she is also currently the head of Center for Automotive Research, a center of excellence at the Faculty of Engineering and Built Environment. And she obtained her Bachelor of Engineering from University Kebangsaan Malaysia, and got her master and doctoral degree from Manchester Metropolitan University, United Kingdom. And she has taught many subjects, both in undergraduate and master level, which also related actually a lot with today's topic, including the engineering design and manufacturing, artificial intelligence in manufacturing, mechanical engineering design, sustainable design and manufacturing, and technology and innovation management, and product innovation and entrepreneurship. And her research interest is actually quite wide and related a lot with today's topic too. And if you some of you have time, probably you can check her publication letter check in her Google Scholar. Her research interests including the product design for environmental sustainability, remanufacturing, engineering life cycle, AI application in design and concurrent engineering. So apart from teaching, she also have a lot of publications, and she also active as the evaluation panel for the Ministry of Higher Education Malaysia, and also a trainer for green practice for the manufacturing industry. Okay, again, thank you, Professor Zuraida, for coming. And I would like to introduce Professor Zuraida, and we can start now. Time is yours, Professor.
All right. Thank you and Assalamualaikum dan selamat pagi kepada semua. First of all, I would like to thank the department for inviting me to share some of the knowledge and information that I've gathered so far, from my research and teaching. And also, firstly, I would like to thank the Secretary of Department, Dr. Taufik, for their warm welcome, and Dr. Melinda, who has been working very hard to make this happening for today. But I have to apologize what happened last week. For the last minute disruption to the schedule. It was because I was I contracted COVID at that time, and I hope it doesn't cause any inconvenience to everyone. Okay, I have to apologize for that. And Alhamdulillah, I'm okay now, after 1 week, and inshallah I will spend the rest of the 2 hours sharing with you some information related to sustainable product development. Feel free to stop me at any time during my presentation, because sometimes when we wait until the end, we may forget what to ask because there are too many information sometimes being shared. Is my voice clear, Dr. May?
Clear, Prof.
Yes,
Boleh,
Professor.
Okay, Alhamdulillah. Thank you so much. I will share my screen. Can colleagues see my slides? Entitled Designing Sustainability into Products from Beginning to End of Life.
Yes.
You can,
Chapter.
Okay. All right. Okay, Bismillahirrahmanirrahim. Assalamualaikum again. I will spend the rest of the 1.5 hours, trying to sort of impart some knowledge, based on my experience and also from teaching and research related to product development. This title is very, I'll change this to slide mode, sorry. Okay, the topic is very related to sustainable supply chain or green supply chain, because we are talking, when you talk about supply chain, it is about recalling or recovering components, parts, products, and return it back to the useful life. So in order for that to happen, we have to understand how and why it is important to incorporate environmental sustainability into products. There are so many strategies, and you can actually approach them during the beginning of life of the product, during the middle of life, but all will require planning from the early stage of the product development. We cannot actually sort of decide to recall or recover a product when the product was actually not designed for that purpose. So it takes a long way, it takes a lot of effort, creativity and innovation to make that happen. Okay. So for my presentation this morning, I will cover some terms related to sustainable products, development to resource efficiency, incorporating sustainability from life cycle perspective. What do we mean by life cycle? And then pushing factors. What are the pushing factors for sustainability? I think Dr. May has mentioned just now about SDG and circular economy. Those are some of the pushing factors that somehow, like it or not, we have to move towards designing or making products that are sustainable to the environment. If we are talking about exporting products, for example, to broaden your business, then there are requirements that we need to comply to in terms of environmental commitment on our product to the environment, of course. And then what are the challenges? Of course, there are challenges towards environmentally sustainable products. It is not a very straightforward decision. It involves the commitment from your workers, from resources is actually necessary. Commitment of resources. It involves economy, costing, how people or consumers accepted your product, whether they want to use recycled products, whether they want to use remanufactured products, because the perception of these products which has been used for a single life, sometimes it's not something common or accepted by the consumers. So consumers has got to be educated, to be well informed of their contribution or their decisions when they purchase products. So there's a lot of challenges when you want to go into sustainable products as a manufacturer. Okay, I will share some of the value-added strategies for multiple life cycles. We are quite familiar with recycle, but what about remanufacturing? And there are so many terms related to remanufacturing that can confuse people or the consumers themselves. And then I will also go through some industrial case examples, how enabling technology will support this initiative. And then maybe a few slides on what are the research work at UKM related to sustainable products and how do we move forward, and then my conclusion. Okay. If you're familiar with these terms, I think you are, because you are in the industrial engineering department. I think these are some of the terms that we come across like almost every time. When we say environmentally sustainable products, we have heard about green products. We have also heard about green design, eco-design, environmentally conscious products or environmentally conscious design. So these are some of the terms that have been used for the past many years. But at the end of the day, they are actually talking about environmentally friendly products. They're looking at they're using different terms. Some argued there's no difference between green and sustainable. Actually, it started with green, green products, green design, but that term actually focuses on the technical aspect, more technical. But then we progress towards sustainable product or sustainable design. So when we talk about sustainable products, it is addressing environment, and at the same time, it must also address the other two pillars of sustainable development, which is social as well as the economy. Okay. So if you look at this report from United Nations Annual Report 2017 about resource efficiency, it addresses environment, the three pillars, environment, economy, and social. Environment will look at policies for transition towards green economy and adopt sustainable consumption and production, which is actually one of the SDG targets, sustainable consumption and production. And then also about economy, cooperation between government, businesses, stakeholders, what are the support provided to the industry to make global supply chain more sustainable. It requires a very strong cooperation between government, business, and also stakeholders. And then the social aspect, civil society and individual to live and consume responsibly and sustainably. So meaning this, the society has also got to appreciate, to understand the importance of their decision, and how they actually support the whole life cycle of the product, from recovery until returning it back to the useful life cycle. What is their role? They should understand that. Okay, so with all these three, the integration of all these three elements, we contribute towards resource efficiency, because we know that resources are depleting at the moment. Yeah, that's why now people are moving towards renewable energy, for example. Yeah, looking at other options of material. Yeah, biodegradable material, for example. Yeah, okay. So how do you actually incorporate sustainability into a product life cycle? Yeah, we look at the perspective of product life cycle here, from looking at the beginning of life of the product, and then the middle of life of the product, and also end of life. At every stage of this life cycle, the product actually give an impact. It could be an adverse effect to the environment. So if you are talking about designing sustainability into product, then we have to address all the stages of the product, from beginning of life until end of life. So by definition, beginning of life is the stage where you design and manufacture the product. Yeah, it is actually in the within the sort of the purview or the control of the manufacturer. Yeah, and then it goes to the middle life, middle of life section phase. Yeah, in which the product is distributed. Yeah, it is where the consumers will use the product, and this is where support comes in, which is the servicing, or they do maintenance to the product. Yeah, so that is the middle of life of the product. So until it reaches end of life, the product must not be just disposed, just like that. It has to be planned how you want it to be recovered or retired. If the product cannot be recovered, then how do you dispose them? It has to be disposed safely. Yeah, and consumers have to know how to dispose them safely. Yeah, so a manufacturer is not just to manufacture products or systems, but also to sort of share or educate their user. Yeah, okay. So these are some of the description which I've mentioned just now. Very quickly, I just go through them. For beginning of life, which is the design and manufacturing stage, this is where the product concept is generated and developed. Yeah, it is one of the most difficult part of product development is the concept design. Yeah, coming out with the concept design. Because if you know about product design and development, they go through different stages, from concept design to configuration design to parametric design, and then to detail design. Yeah, to get the concept right is the most challenging in product development. Yeah, because it is at this stage that you require people to sit together, and do brainstorming, come up with needs analysis, talk to the consumers or customers. I will talk about that later on in more detail. Okay, and then as I mentioned just now, it requires needs analysis. You have to clarify your design objective. If you think that your product needs to be recovered at the end of their life cycle, then it has to be one of the design objectives. You have to incorporate that in your QFD, quality function deployment, and work towards how you want to actually address that objective. If it is not sort of identified from the start, and then somehow during the development stage, you will miss out on that important requirement for sustainability or for green initiatives. There are many tools and techniques to support creativity, innovation, and good design. It involves a lot of techniques. I think all of you maybe have been taught on product design, I believe, because you're under the industrial engineering or industrial management program. We talk about product development. We start with identifying the problem. Then there's so many other tools that can help you. When you go into parametric design, for example, when you give parameters to your design, there's a lot of software that can help you. But the concept design is always the most difficult, because you need people to sit together, to brainstorm, to generate ideas, to select concepts. There are tools to help you, but there's a lot of human thinking required at that stage. And then data and information sharing is crucial. If you talk about data information sharing, this has been addressed as a very important and necessary activity in product development, and is gaining more significance now. Yeah. In the 70s, people talk about, in the 90s, people talk about concurrent engineering. Yeah. People has actually started talking about data and information sharing. Yeah. And now with a lot more approaches, a lot more strategies in product development, this has become more important. Yeah, more and more important now. Okay. In the middle of life, which is the distribution, use and support, where we do repair and maintenance of the product. This is a very important stage in that you have to monitor, or you have to share information, or you have to sort of monitor how the product is being used, how the product is being distributed, because that has a lot of impact to the environment. You need to communicate with your consumers, for example, how they use the product. Is it used in the right way? Sometimes products are not used as what they have been designed for, because it is sometimes beyond your control as a designer, because it has already reached the consumers. If they are not well educated, they may not be using the product. They may not be handling the product in the right way, and there may be some impact to the environment. Some products are 24 hours sort of providing some or impacting the environment. Some we use them occasionally. For example, an iron, Straker iron. It will consume energy when you use it, but as compared to products like refrigerator, for example, or products that you have to use 24 hours, 7 days a week, then they have more impact to the environment. We have to actually, that kind of study will require energy audit. Energy audit to understand the impact of the product to the environment. Okay. So information related to the impact of product to social, economy, environment needs to be collected and monitored. And this is also very important that you get customer feedback, failure data, what kind of failure, what kind of damage that can happen to your product, and how it can be actually repaired. It is very important that maintenance is incorporated into your design for maintenance, design for servicing, because these elements will ensure that your product has a long life. It is easy to repair, and therefore you can extend the life of the product. Why is that important? Because when you extend the life of the product, there is no need for you to develop new products all the time when your product has reached its end of life. So these are some of the contributions of manufacturers in order to extend the life of the product. People say, why do you need to extend? It is because when you extend the life, you don't have to buy new products every time. So I think that's a basic understanding that manufacturer has to understand, incorporate design for ease of maintenance into their product. That is very important. There's a book on design, mechanical engineering design by Dieter. Dieter is a German author, but I think there are many versions of that book now. That book does mention about some products were purposely designed not to facilitate servicing and maintenance. That is very true. Perhaps maybe in the past, because manufacturers would want to make more profit every time, make new products, sell them, because they sell at a better price compared to second-hand products or used products. But there are many pushing factors now, that require manufacturers to go back, to their drawing board, and their design team and see how they can actually facilitate maintenance, because these are some of the corporate social responsibilities, yeah, that some companies have to report. Yeah. Okay. And then at the end of life, this is very related to sustainable supply chain. Yeah. When you design the product, you have to think about the possibility of reverse logistics, yeah, the closed loop supply chain. How can we contribute towards that? So to make sure that that happens at the design stage, make sure that the product can be recovered or recalled, yeah, through different strategies, yeah, and working very hard with the suppliers and your consumers, yeah, or your customers, and also the distributors, of course. Yeah. Okay. This is just to sort of to picture, yeah, what I have mentioned just now at the beginning of life of the product, yeah, and then it goes to the middle of life and end of life. So at the beginning of life, there's a lot of sort of requirements that you need to consider, yeah, information that you need to capture, okay, and as well as knowledge, yeah, heuristics, experience, yeah, on how to actually make products that are sustainable to the environment. Yeah, if we look at the tools and techniques, there's a lot of tools and techniques that can support the team, you know, during product design. But they must know how and where to get the information. Yeah, they have to work very closely with their customers, with the government, yeah, stakeholders, and also their suppliers and also business partners to incorporate all this requirement of sustainability into their product. Yeah, because relatively, if we compare requirements for human factors, ergonomics, for example, yeah, requirement for ease of manufacture, requirement for ease of assembly, DFMA, yeah, requirement for design for reliability. These requirements, or DFX, yeah, as shown in the middle of life, they're quite established. Yeah, they're quite established. The design guidelines and rules have been established. For example, like design for manufacture, yeah, and assembly. These guidelines have been available since, I think, the 70s, yeah, by Boothroyd and Dewhurst. And a designer can actually use their software, yeah, the DFMA software, to assist them in designing product for ease of manufacture and assembly. Yeah, but designing for sustainability or design for environment, yeah, it is relatively new, and industry is actually picking up. Yeah, some are picking up very fast, yeah, and some are picking up very slowly. Yeah, I can say this because I understand the practice of the industry in Malaysia, for example. Yeah, if I just quote certified remanufacturing company, yeah, in Malaysia, there are only about less than 15, yeah, and only a few are still in the process of getting certified. There are many recyclers, yeah. There's a big association of recyclers in Malaysia, but for remanufacturers, they are still sort of at the early stage. Yeah? We have less than 15 being certified. The government knows that there are many companies that claim they do remanufacturing, yeah, but when they want to be certified, yeah, their practice have to follow a certain standard. Malaysia has got a Malaysian standard for remanufacturing, so these companies will have to follow the standards, yeah, and they must comply to the standards. So far, about less than 15, I think about 12 or 13 has been certified. Yeah, so there's a lot of information that needs to be acquired, yeah, about sustainability. As I said, industry has to work very closely with the government, yeah, their business partners, their suppliers, universities. Yeah, universities may have a lot of information, may be able to advise, but they will also want to work with industry, yeah, to apply the knowledge that they have. So it is very important, the integration between all these interested parties in order to contribute towards product sustainable product. Okay, right. End of life, as I mentioned just now, includes reuse, recycling, and remanufacturing. So it is easy, I think. There are many approaches to looking at how product can be designed for sustainability. Yeah, but one of the simplest approach is looking at the life cycle. Yeah, looking at beginning of life, what do you do? Yeah, middle of life, how is the product impacting, and how do you incorporate these requirements? Yeah? And then, of course, at the end of life, yeah, what do you do? Is it recycling? Is it remanufacturing? Is it just simply reusing of the product? Yeah. Okay. So how does a product actually impact the environment? Yeah. There are many ways of how a product can actually impact the environment. Yeah. Decisions made during design and manufacturing stages, yeah, has a lot of repercussions, yeah, on the sustainability of a product. It can be from the perspective of material, yeah, the material that you choose, yeah, the design of the product, you know, the process that you decide, yeah, on how to make the product, what are the chemicals and additives, yeah, and toxic and harmful effluents, releases to the environment, and also the energy. Just excuse me for a while. Eh? Hello, saya ada kelas at the moment. Sorry, yeah. Okay, so these are just some of the elements, yeah, that has some impact to the environment, yeah, and decisions on these items, yeah, has to be made wisely, yeah, during the beginning of life stage, yeah. For example, on material, if you choose low durable material, yeah, meaning in bahasa we call it tahan lasak, yeah. Okay, ketahanan bahan. Okay, if the product is of low durability, surely that product will reach end of life faster, yeah, and it cannot be recovered for purpose of reuse, yeah, or remanufacture. Yes, so the decision has to be made. If you want your product to be remanufactured, yeah, then you have to decide on materials that are of high durability. Okay, and then, for example, products that cannot be reused, yeah, cannot be recycled. Yeah, if you use some plastic material, you must know what are the plastic material that can be recycled, yeah, can be reused again. Okay, and if it is non-biodegradable, yeah, how does it impact the environment? How do you dispose them? Yeah, if it is of low durability and non-recycle, yeah, and it is also at the same time non-biodegradable, yeah, how do you make decisions on that in terms of sustainability? Yeah, in terms of design, for example, yeah, if your product has been designed with poor consideration, yeah, of EOL, end of life, yeah, that is one issue. Also, it's not just that, the configuration of the design has to be really discussed in detail, really a design into the product. For example, when you talk about configuration, it is of course about the arrangement of parts and components, yeah, about the material, about the selection of the process. Yeah. If you decide this decision on the type of fastener, for example, yeah, is in the configuration design stage. If you are talking about remanufacturing, yeah, you want your product to be remanufactured, do you think assembly method using welding is a wise decision? Do you think the use of snap fits, for example, yeah, is it okay if you want to recover your product at the end of life? So these are some of the decisions. How do you arrange your component? Is it, if you want a modular design as opposed to a integral design, yeah, you want products to be maintained easily for a longer lifetime, then you may opt for modular design. Yeah, those are some of the considerations that you need to consider at the design stage. Yeah. And then about process. Yeah? Do you want to use additive processes, or you want to use subtractive processes? Yeah, where possible, use additive manufacturing, for example, because additive manufacturing, in terms of material wastage, it is sort of lesser, claimed to be more environmental friendly. Yeah, and then chemicals and additives. What are the chemicals and additives that you selected? Yeah, in order to process your product or your formulation or your systems. Yeah? And then you must know how to actually handle this kind of effluents. Yeah? Okay, and then releases to the environment in terms of emission. Yeah, how do you prevent emission? How do you control? How do you mitigate? Yeah? All this will has a lot of impact, yeah, to the environment, and decisions on this has to be made at the design stage. Yeah? And then what are the energy type? Yeah, what are the energy type and the intensity? Yeah? In terms of non-renewable energy, for example, to replace renewable energy to replace non-renewable energy that you use in your industry, for example. Yeah? And then high energy consumption. You know, you may look at other options. People are talking about the use of recycling water, for example. Yeah, recycle water. Okay, how do you harvest water? Yeah, okay. These are some of the strategies or the items that you need to think, or to think in detail, yeah, at the design stage. This is a teamwork. It is not a one-person decision. Yeah, it requires a teamwork and people with different knowledge and background to make decisions on this. Yeah, okay. I will now talk about the pushing factors for sustainable product development. There are many pushing factors. It could be at the international level, yeah, and also maybe at the domestic or the national level. Our government has put in place some strategies, yeah, to align to the linear economy as well as the SDG, for example. Yeah. Okay, what is linear economy? I think everyone may be familiar with this. Yeah. The concept is linear economy is to take material, yeah, for example, from the mining site or from plantation, yeah, and then they manufacture, they make, and then after single use, they are disposed. Yeah. At that time, people would only understand recycling, yeah, as one of the best strategy. So they would think of types of material and other strategies in design that will enable this product to be recycled. But now we move on to circular economy. Yeah, we make, we use them, and we return them. Yeah, return can be a return to the manufacturer or return to independent third parties, for example. Yeah, to process them and return them into the useful life cycle, back into the useful life cycle. Yeah. Otherwise, if the product cannot be recovered, then they have to be disposed in a very safe manner. Yeah. Okay. So this is a very simple, okay, diagrammatic representation of what is linear economy and how it is also the representation of the circular economy. Yeah. They focus also on biological material as well as technical material. Yeah. If you look at the loops, yeah, in the technical material, they talk about maintenance, yeah, reuse and redistribute, okay, refurbish or remanufacture, and also recycle. So these are some of the strategy that has been proposed by United Nations, yeah, on how to address the circular economy. Yeah, basically the aim is to extend the life of the product wherever possible. Yeah. So this is the definition which I've mentioned just now. Yeah, I'll just skip this. And why the need for a circular economy? Yeah, it is very important because there is a progressive shortage of primary raw material. Yeah, resources are depleting. There is a reduction of space. Yeah, for final disposal of waste, Yeah. And then at the same time, increasing global consumption of non-renewable resources. We want to reduce quantity and volume of waste generated. We want to control environmental contamination caused by emission, yeah, from waste treatment. And we also want to focus on changing social attitudes, yeah, towards waste management. This is a very important element for the success contributing towards circular economy, because if we focus on just the element of environment and also the economy, but the social aspect is not addressed, yeah, then it is very difficult for us to move towards sustainable development, because the person or the community, yeah, has to contribute by making decisions on what products to buy, how to dispose them, how to handle them safely, for example. Yeah. So education of the society or the community is very important. So with a circular economy, we hope, yeah, we can change, yeah, social attitudes towards waste management. If we look at some simple principles of circular economy, yeah, as what World Economic Forum, WEC, has outlined, yeah, it is a very sort of optimistic, of course, view of circular economy, yeah, but it is not impossible, yeah, because we have newer technology, yeah, that can actually support this. Yeah, waste do not exist. That is what they said. Yeah, waste do not exist. Products are designed and optimized for a cycle of disassembly and reuse. Yeah? I have read an article by some Japanese authors. Yeah? They claim, it was not a new paper, I think it was a 2014 publication. They talk about some engines, yeah? Like Perkin-Elmer, they are designed, they are very durable. Yeah, the quality is very good. Sometimes, you know, this kind of engines can be reused up to 6 times. They reach end of life, they undergo restoration, they remanufacture, use it again, yeah, and it reaches end of life, recovered and restored again, yeah, up to 6 times. This is possible because the product was actually designed in the first place for that purpose. Yeah, because we know that engines like aircraft, yeah, they are very costly, yeah, and it is of high value, and therefore they can be remanufactured and reused. Yeah, so decisions on products that can be remanufactured or reused, yeah, you, as a designer, we have to make sure that it is durable, and also these products are of high value, yeah, so that it is worth remanufactured and using it again. Because there are a lot of arguments on why do we use reuse product or second-hand product when the new products are equally cheaper or not that expensive. Yeah, so it is very wise. Yeah, designer must focus on product that is of high value if you want to remanufacture them. Okay. And then products of biological ingredient, yeah, they have the technical and biological parts, yeah, in circular economy. If possible, that can be returned to the biosphere, either directly or in a cascade of consecutive uses. Products which are durable, like engines or computers, are designed for reuse. Yeah? Products subject to rapid technological advance are designed for upgrade. Durable products are leased, rented, or shared wherever possible. So, for example, like upgrade, yeah, upgrade is not straightforward. It is quite challenging, yeah, because in order for you to make sure that your product can be upgraded, you have to do an upgrade plan. You have to know the technology, you have to do technology forecasting, for example. You have to design the product in a very flexible design, flexible manner, so that your product can be upgraded when necessary. Yeah, so it is one of the strategies for extending product life. Yeah, but it is of course quite challenging. Yeah, but that is possible with a good upgrade plan in place. Yeah, so upgrade, sometimes in some industry, they don't call it upgrade, they call it like retrofit, refit. Yeah? For example, in the marine industry, I think they call it refit or retrofit. Yeah? So it is quite the same as upgrade. Yeah, what we mean by upgrade. Okay, just let me check the time. How many more minutes, Dr. May, do I have?
You only use 40 minutes up until now, so we still have, I think, another 40 minutes. Wait,
Another 40 minutes.
50
yeah,
minutes,
okay.
sorry, 50 minutes. Yeah.
All right, okay. All right. I have about 50 minutes.
Yes, 50 minutes, Professor.
50, yeah? 50, is it, Dr. May?
Yes, 50.
All right, okay. So I have plenty of time actually. Okay, right. This is another pushing factor. I think everyone is aware, yeah, about sustainable development goals. Yeah, there are 17, yeah, altogether. And if we look at all these targets, yeah, many of these targets are related to sustainability. Yeah, this is a target adopted by United Nations in 2015, quite recent actually. Yeah, 2015. This is to a call, yeah, for the world to end poverty, protect the planet, and ensure that by 2030, they have a target, yeah, by 2030, all people enjoy peace and prosperity. So if you look at the all 17 targets of the United Nations for SDG, yeah, if you go through good health and well-being, yeah, clean water and sanitation, yeah, affordable and clean energy, okay, these are related to sustainability. Yeah, industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and production, yeah, all these are very much related to sustainable development actually. Yeah, retaining life below water, making sure that they are healthy, yeah, life on land, for example, all these are the positive side of sustainability. Yeah, if we actually work towards sustainable development. Yeah. Okay. So how do you actually approach? I think, okay, we have seen some strategies being shared with the community. Yeah. In Malaysia, for example, there's a very good sort of education, yeah, for the community, for the 3R strategies, yeah, where you reduce, reuse, and recycle. Yeah, we started with 3R. Yeah, 3R, even though the implementation is still not up to the expectation of the government, yeah, in terms of 3R. Yeah, because this 3R is not only for industry but also for the community to practice. Yeah, but slowly, yeah, we are improving and moving towards a better sort of a better commitment, yeah, towards a 3R. So in the industry should move, yeah, should be moving towards 6R strategy, in which it is we retain the 3R, yeah, reduce, reuse, and recycle, but other 3R has been added, which is recovery, yeah, redesign of products, and also remanufacture. Some are talking about 7R, yeah, but I think it's best that we stick to the 6R for now, because even our 3R in Malaysia is still, you know, not to say not implemented, but we are moving towards that, and we are improving a lot. Yeah. But now the industry has to focus more on the 6R in their product development. They have to think about how to recover their product. Yeah. If there is a need to redesign their product, then they have to. Yeah. Especially if they were to export their products overseas, where the requirements are more stringent in terms of corporate responsibility and so on. Yeah. Excuse me. And then this is more of the circular economy concept, yeah, which is regenerative and restorative. They focus on reuse, remanufacture, upgrades, and maintenance. Yeah? So throughout this product development, it will require a life cycle thinking, from single-use product to multiple life cycle products. Yeah? So if, for example, the industry has started with the 6R strategy, that means they are starting to commit, yeah, on how to improve their product. Maybe earlier on, their product are not designed for purpose of recovery, for example, yeah, for purpose of design, for purpose of energy efficiency, for example, yeah. So this is when they can start looking at how they can actually improve their products through redesigning of the product. Yeah? They may need to redesign their product so that their product can be recovered easily. They will decide whether they want it to be recycled or they want it to be remanufactured. For example, if you are an automotive equipment or component manufacturer, yeah, it is very common that parts like alternator, starters, yeah, brake calipers, cylinder heads, being remanufactured, not just in Malaysia, but also in many other parts of the world, especially in Europe. Yeah? So they must also have a conscious mind, yeah, on how their product can actually be improved to facilitate this remanufacturing process. Yeah? Because they have a social contribution of offering, yeah, offering their customers new products as well as product that can perform equally good but can be sold at a cheaper price. Yeah? Because remanufactured products can be sold at a price of 40 to 60% cheaper than new products. Yeah? Equally, for example, a new alternator, yeah, as compared to a remanufactured alternator, this alternator, the remanufactured alternator, can be about 50% cheaper, yeah, than the new alternator. So maybe in the past, yeah, industries are very much into just making profit, want to sell new products, yeah. But now, because of the pressure, yeah, pressure from the government, pressure from the pushing factors like the SDG and also the circular economy, yeah. So somehow they will sort of they are forced, yeah, to be innovative in order to improve their design and to facilitate recovery. Yeah? So life cycle thinking is a very important concept, yeah, in product development today. Yeah? So there's another pushing factor, which is the ESG standard. This is not just in Malaysia, but it's all over, yeah, at the international level. The push towards ESG for companies, yeah, these are sort of some standards. In fact, in Malaysia, there's a lot of already, yeah, a lot of news sharing, yeah, with the community and also the industry on the importance of the ESG. In fact, banks, yeah, Bank Negara Malaysia, for example, and other banks, industry banks, SME banks, for example, they would require companies, yeah, before they make loans, for example, to prove, yeah, that their business, yeah, is actually considering the ESG. What ESG is? E is environment, S is the social aspect, and G is the governance. Yeah? So these companies or industry, if they want to work with their partners, for example, or they want to make loans, yeah, from banks, they have to report on this kind of initiatives, yeah, to the banks. For example, if they, about environment, the E element, the E component, yeah, they have to prove that they have contributed towards climate change and carbon emission. Yeah, what is their initiative on water and air pollution? How do they address energy efficiency? Yeah? Wastewater, for example. Yeah, how do they recycle water? Water scarcity, how do they address scarcity, yeah, in their business? Deforestation, if they are involved in deforestation, yeah, what is their initiative, yeah, to sort of plant trees, for example, yeah, to avoid a landslide, for example? What is their contribution? Yeah. And this is actually a very good sort of push, yeah, for the industry. Like it or not, they have to sort of address some of these items. Yeah. On the social aspect, they will be sort of checked. Yeah? The bank, for example, will see, yeah, what is their initiative on human rights, yeah, employee engagement, customer satisfaction, data protection and privacy, community relations, and others. So these are the their contribution to the social aspect. Yeah? And then governance, yeah, what is the industry initiative on, for example, do they have standards on bribery and corruption? Who are their board members? Yeah, board members. Perhaps they would want to see whether there are people from the ministry, yeah, that can advise the company on environmental aspects. Yeah. If they do audit, who is their actually audit committee? Do they have a whistleblower scheme? This is necessary now. Yeah, people are talking about company integrity. Who is going to blow the whistle if there's some malpractice, for example? Yeah. Okay. This is actually a very important pushing factor, yeah, for environmental sustainability. There are a few companies in Malaysia that has been sort of their products have been could not enter, could not enter the United States, at one time, because there are reports saying that these companies did not take care or be very conscious about the welfare of their workers. Big companies, like Top Glove, millions of their exports to US has been declined, because there has been a lot of reports saying that these companies, they produce a lot, but they do not take care of their workers at one point. And this is a big issue. There's another supplier that manufacture parts and component and supply to Dyson, Dyson, the company that manufacture vacuum cleaners and electrical items. That company has also, not Dyson, the supplier, Dyson has actually stopped their supply from entering Dyson at one point because of the same issue. There's no issue on product quality, but the company did not actually take good care of the welfare of their staff, was not actually taken care by this company. Okay, so nowadays it is the ESG standards that companies have in Malaysia, for example. It's not just Malaysia but also overseas. When they want to partner with companies, they want to see this kind of initiatives in the company. Okay, going back to the design perspective, multiple life cycle here, excuse me. Multiple life cycle here is meaning that the product is used many times. Reach end of life, repaired, restored, and used again. It can be reused, it can be remanufactured. Okay. There are challenges in multiple life cycle from design perspective. Normally it is because of poor design. The independent remanufacturer or the industry who wants to recover or restore the component could not do it in a good way or could not recover the product in a good condition because of poor design. That could be due to manufacturers like inappropriate choice of fasteners. For example, if you use welding, how do you separate parts and components later on? For example, if the parts of the material are of different material, if you use welding, so how do you actually disassemble them nicely so that you won't damage the component? Yeah, is screw the best option? Is rivet the best option? You have to consider that if you decide on the way to recover your product. Yeah. And then difficulty in disassembly and reassembly. Yeah, sometimes you can disassemble the product because they use screws, for example, easy to disassemble. Yeah, and because they use modular design, but you have difficulty in trying to reassemble them later on. Yeah, and then difficulty in testing and inspection. Yeah, if you want to remanufacture parts and component, it has to be tested. It is not like recycling, where you just melt the material, virgin material, and you convert it into another product. Yeah, for example, if you recycle a mineral water bottle, you can then use the recycled plastic to make rugs, for example, carpet, for example, yeah, or a doormat. Yeah. But when you come to remanufacturing, you have to make sure that the product has been tested, yes, because it has to attain the specification, original specification of the product, if you want it to be labeled as a remanufactured product. Yeah. And then difficulty in part replacement and servicing, yeah, because the product was not actually designed for purpose of maintenance and servicing. Yeah. So, for example, when you talk about architecture of a product, yeah, architecture of a product, you arrange part and components, yeah, in a way that it is easy to replace, yeah, or to repair parts, yeah, that you think after a while, after a certain life cycle, it will need replacement. So how do you actually locate, or how do you arrange this modular component in your design? Yeah. So that has an impact on difficulty, yeah, in part replacement and servicing, if it is not actually designed for that purpose. So when you want to recover parts and components, there are a lot of design for X requirement that you have to actually consider. Yeah. And then proliferations of material in construction. There are so many different types of material that will require different kind of recovery. Yeah. For example, you use metal and you combine with some hybrid material, yeah, or some plastic material. So this different material will require different recovery strategies. Yeah? So if you look at the 3R strategy, yeah, one of it is reduce. Yeah? The suggestion is to reduce material consumption. Yeah, so that is one strategy, yeah, that you can actually look at if you want to design product for multiple life cycle. Yeah? Is there any question so far?
So is there any participant that wants to ask question to Professor Zuraida up to this point? So actually, I have some questions, Professor, that I don't know whether should I, yeah. So
yeah, please.
Actually, at the beginning, you mentioned about the commitment of resources itself, and then you most likely told also about the beginning of life, the middle of life, and also the end of life. And then I was wondering on how, I think from the perspective from Malaysian, I think, yes, how to actually educate the whole parties about that, about this, the concept of the circular economy itself, because you mentioned that it should be from the manufacturer, but it's not only for the manufacturer, but also from the perspective of the customer, they also need to be educated, right? So
yeah,
what kind of education should we give to the customer itself? Yeah.
Thank you, Dr. May, for the question. It's a very good question, actually. There are many stakeholders that can actually contribute towards the providing education, awareness, yeah, to the society, to the industry. For example, in Malaysia, at the moment, the Malaysian Green Technology Corporation, under the Ministry of Environment and Water, they have a series of training on green practices. Yeah, they invite manufacturers, not just manufacturer, but they divide into different disciplines. One group on forestry, one group on mining industry, another on manufacturing. So there are many different sectors that they have identified, and they are actively training this industry on what is green practices, on what are the labeling that we have, like My Hijau labels in Malaysia. They sort of encourage industry to come for the My Hijau sticker on their product. So that training just started, I think, this year. And they invited, of course, some academicians, to share with the industry. And that's one thing that we can do, that has been done by the ministry. But of course, it is like not all industry wants to, join once they are being invited. It is for free, Dr. May. It's not, they have to pay, it's free. They can come and they organize that training like one full day, just an introduction. And they introduce not just the concepts of green manufacturing, but also what are the standards that we have, what are the Akta Alam Sekitar, for example, and then what are the initiatives that the government can do, can help the industry, for example, a tax rebate, for example, all these are actually given to the industry. So, but not all industry willing to come, so they have a hard time actually, to force them to come. And I have been involved with at least two of the sessions, and I would expect more industry to come, of course. But slowly, I think the ministry is trying to approach the industry through associations, for example. If they can get the association to come, then it will be good, because under associations there are many members. If the directive comes from the chairman of the association, then it will be very, very good for the industry. Okay, another thing is we can write articles in newspapers, in mainstream articles, for example. I have tried actually writing some, I've sent twice actually, maybe I should send more, on what is the impact of design to the circular economy, what is remanufacturing, for example. I think academician can play that very important role. And also you can also work with the ministries, to actually share some of the knowledge, because in the university we do research. We do research and we understand the difficulty, so we can share that with the industry. I think that is the initiative that we can do. But we have to work very closely with industry, the ministry, and also the academia. The public, it is very important that the public is aware. We may go down to the very low level. We have to go down to the low level to sort of educate public, through writing, maybe through television, through social network, for example, to educate them that remanufactured product, for example, is not substandard. This product has been tested and brought to the level of original specification. This kind of knowledge is not readily available. I mean, public do not know this. They know recycling, but they don't know remanufacturing. Not many. Okay, they have to be really exposed to this kind of initiatives. The National Automotive Policy in Malaysia, it started in 2014. And they have started to address remanufacturing, recycling, and all that for automotives. And then it was further emphasized in NAP, National Automotive Policy 2020. And the ministry, our MITI, International Trade and Industry, has come up with Malaysian standards, and all this. Our ministry is actually educating the public as well with the use of the policy and also the standards. Yeah. But this is ongoing. We cannot stop here because from my experience with the industry, involved with 2 sessions of introduction to green practices in manufacturing, some of them are really at the initial or the first level, so-called. They know some are advanced, some are advanced, but the small and medium industry, normally they are just being exposed, and they are sort of keen to start with some initiatives like they want to recycle water, they want to harvest rain, for example. So I think that is quite a good move, after understanding. So they start small, because it requires some long-term and short-term initiatives also. I hope that answers your question, Dr. May.
Yeah, it's kind of like a lot of homework, I believe, because it requires a lot of, how to say, like you say, multiple stakeholders to actually and commitment to actually achieve that. And in Indonesia itself, I think the concept of circular economy just being introduced, I think, in 2017, where there is this regulation. Not so prior to that, there is no regulation, and then in 2017 we have regulation regarding the waste itself, and then the concept of circular economy is actually quite new. However, I also find out some of the company that already focusing on remanufacturing, refurbishing. So I think it's kind of like one step, led to another. And
because
actually,
sorry, Dr. May.
Yeah, I still have more questions, but please continue.
Okay. Now we can, if you do not want to ask it now, we can ask them during the end of the session, maybe.
Sure.
Yeah. Okay. I know there's a number of companies in Indonesia doing remanufacturing, because I read publications on remanufacturing from Indonesia, and there are some companies doing remanufacturing of turbochargers, for example. Then I think that's a good move there. Okay.
There are a question from the participant on the chat. I will read it for you, Professor Zulaida. I hope you don't mind.
Okay.
So the question is from Felahiati. She is from Polytechnic of ATI Makassar. So the first question is, what actually the main obstacle in establish circular economy in developing countries? Because we actually heard a lot of successful story before, but mainly come from a developed country in Europe. And the second question is regarding the developing countries like Indonesia. Actually, which cycle should we focus better, whether it's the beginning of life or middle of life or end of life? Yeah, that's the question, Professor.
Okay. Which is a better to focus on, is it?
Yes.
All right, okay. I did not get the first question, Dr. May. Can you repeat again?
So the first question is, what actually the main obstacle, probably like challenges in establishing or I think implementing circular economy in developing countries, because the successful story mostly come from developed countries. So there might be a gap, right, between developing and developed countries.
Yes. So, okay. All right. Okay, maybe I should address the first one on the obstacles in developing countries. Yes, there are obstacles. The first thing that we need to address is the knowledge. The knowledge on how to. I did a study in 2009. 2009. It was a paper with my student at the time, Arwah Dr. Lily Emilia. She wrote a very good paper and has been cited by several times. It is talking about the lack of knowledge and expertise on how to remanufacture, for example, what to remanufacture, how to improve design. So a simple approach is to work together, yeah, to work with suppliers, to work with sister companies, for example, to work with university, yeah, to work with ministries, yeah, because these different stakeholders can contribute in a different way. Yeah, for example, if you work with a university, inshallah, yeah, they know what is supposed to be the right way. They know, yeah, but we have to work with the industry to really understand how this can be implemented. There can be several guidelines, there can be several rules, yeah. There can be many software that can help, yeah, but we have to really go down and see how this can be implemented. Yeah, so every industry, for example, yeah, has to start small and grow. Yeah, look at how their product can contribute. For example, when I talked to some companies in Malaysia the other day, they said, okay, when they go back to their company, they want to start with recycling water, for example. Okay, some started already slowly to use more of solar energy. Okay, that is considered advanced to me. That's good. Yeah, to collect rainwater, harvesting of rainwater is actually one of the green practices, yeah, that you can actually contribute. Okay, how do you harvest rain? Yeah, there is sort of a technology, yeah, that can help you to harvest rain. And then, for example, to reduce energy consumption, yeah, from using incandescent lamp, you can use LED, for example. You know, these are slowly the green practices that you can implement. Yeah. For example, if you're talking about recovery, okay, for example, if you're talking about recovery, your product cannot be recovered because it is not durable. The material that you use will be damaged easily. Yeah, for example, after a few months of using, it damages. Then you cannot actually reuse it again. So is it really worthwhile for you to remanufacture your product? Is your product of a very costly component? Is it of high value? If not, then think about how you recycle your product, how it can be recycled. Yeah, so you can start with recycling, thinking about how to recycle. Then slowly you talk about how to reuse your product, how to remanufacture the product. So it requires, yes, it requires some creativity and innovation, yeah, to start with, especially in the design team. Yeah. There are many design contribution that can help you, design aspect that can help you to improve your design. Maybe you can focus on the 6R strategy, yeah, or the 3R strategy. Start with 3R. Yeah? Reduce means reduce the consumption of material. Recycle. Yeah? Reduce, reuse, and recycle. Where possible, you can reuse your parts and components. Yeah? For example, if you are talking about an engine, yeah, there are parts that the cylinder head, for example, engine, yeah, cylinder head you can remanufacture. Yes, some other parts of the engine, for example, piston, for example. Yeah, some claim they remanufacture piston, yeah, and some said they replace. Okay, so it needs a team, yeah, to sit and look not just on the design aspect. You can also look at from the process aspect. Yeah, what are the chemicals that you use? Yeah, what are the emission? You have to do an audit, so called, yeah, to understand all that. So you have to work in a team and get the right stakeholder to assist. I do not know what is the incentives that government in Indonesia can provide. I think there are many, yeah, because I just came to know from my colleagues in the Malaysian Green Tech Corporation recently, a few months back, that there are many standards, many initiatives, for example, yeah, provided by the government. In terms of tax, for example, you can have tax exemption, carbon pricing, yeah, carbon pricing. The government will put a cap, yeah, on your emission of carbon. Okay, if you don't actually sort of exceed, yeah, that cap, then you can sell, you can give that to another company. That is the kind of carbon pricing mechanism. Yeah. In some countries, when you export your product, they will want to see evidence that you have actually, you know, the emission, carbon emission, you have done energy audit, for example. Yeah. So if not, then they will sort of disallow the company to send their products there. Or maybe you have to prove them that, you know, you have some initiatives and so-called initiatives, green initiatives in place. So things can be difficult if the accepting country is stringent about this. So I think it's best time for you to, you know, start the initiative, look at how you can improve. You have to work with the right people, basically, Dr. May, and students. You know who to address, you know who to approach, in different perspective. Okay, Dr. May?
Yeah, okay,
All
thank you,
right.
Prof. And then there's another question. Is it
Uh-huh.
okay, or should I push back to at the end of the session?
I think you can ask the question now. I'll try to simplify it.
Okay, the question is from Imran from Universitas Trunojoyo, Madura. How to handle the uncertain quality of the end of life product for remanufacturing?
Uncertain quality, yeah?
Yes.
Okay. All right. When we talk about end of life, there are many strategies, which is I'll talk about just three, okay, or two, the significant ones. Recycling and remanufacturing. Maybe these two, because these two has a stark difference between them. Okay, recycling is a process where the aim is to recover material. You do not want the part and component anymore. You just want the material, because to you the material is important, is significant, and you can do business with it. Yeah. Okay. So the product therefore has to be labeled properly. When you design your product, you ensure that it is labeled properly, whether it's polyethylene, if plastic, whether it's PP, polypropylene, polyethylene, for example. They have a specific symbol for that, for this different kind of plastic. The Society for Plastic Industry, the SPI, has come up with different numbering for plastics to reflect that it can be recycled and it is that kind of plastic. For example, polyethylene, PET, I think is one, if not mistaken. They have that label on the mineral bottle, for example. Okay, so you recycle them, you just one material. So make sure that when you recycle, it is of virgin material. You don't mix plastic material when you recycle them. That is not the right way to do that. Okay. So it is turn out to be a different product. Turn out to be a different product. For example, mineral water becomes a carpet or a rug. So okay. So there's not so much issue of quality there. Because it is processed and turned into a different product. But remanufacturing, the definition of remanufacturing is actually very stringent. That's why not many companies can actually comply for certification in Malaysia. Because the definition is recovery or restore products to its original specification or better. How can it be better? It can be better because you may be putting using part replacement, part which of more superior design, for example, of superior material into the reman component. Okay, here it is very important that once the product has been remanufactured, for example, alternator or a starter, or a brake caliper, or even turbochargers, you have to label them properly. It has to be labeled. It's not in Malaysia, the standard says it's not labeled on the a sticker, for example. No, it has to be sort of embossed on the component itself. And the box must say that this is a remanufactured component. So there's a proper labeling of this component to make sure that it is not being resell as reman component, and you know that it has not been tested or verified. The quality has not been verified to that level. So remanufactured component has to be tested, given a warranty, and labeled as a reman component. So customers or consumers should not be worried about the quality of the reman component if it is labeled properly, tested and labeled properly. Is there a standard already in Indonesia about remanufacturing so far?
I don't really have an update about that, but I think it should because there are many companies that are already working for the remanufacturing or refurbishment. I think they already have standards.
Yes. There must be some, if not a Malaysian standard, if not a country standard, it can be industry standard. As long as it meets the requirement of the component, the requirement of the industry. In Malaysia, we have a Malaysian standard on the remanufacturing. It is a requirement, or the type of activities that you have to perform on an end-of-life component in order for it to be called a remanufactured component. And then we have also this remanufacturing policy, national remanufacturing policy. It was actually approved already by the government, and it was our Malaysian MITI, that International Trade and Industry, that come up with a policy. And because of that, slowly more companies are actually working towards their product being reman. There is a company, for example, in Malaysia, they call it, the company is MTI, Motor Trade Industry. They do a remanufacturing of engine. Normally it's a diesel engine, and they get their engines. This company, they get their engines from their customer. It is very, very. It is not from just from any person in the society, for example, wants to send. They have their own client. For example, Mercedes-Benz, send their diesel engine to be remanufactured in MTI. So the specification that they have to attain after remanufacturing this product is from Mercedes-Benz. So it is easier that way as compared to if you don't know what is the specification of that component that comes to your company. So it's easier if you know who the customers are, and they would have their own specification with them. So it's easier for you to process or remanufacture them and attain the specification as what the customer wants. If you are independent remanufacturer, then it's more challenging because sometimes you don't have the specification. That is one of the challenges in doing remanufacturing. So if you don't have the specification, sometimes you have to sort of do reverse engineering, in order for you to know what is actually the specification. Okay, can I continue? Is that answering your question about uncertainty in the quality?
So, Mas Imran, is Professor already answered the question?
Yeah.
Yes, thank you, Professor Udraita.
All right. Okay, thank you. You can ask more afterwards, okay? If you think it is still not clear.
Okay, thank you.
Okay. I'll continue. These are some of the...
Professor.
Yeah, thank you. These are some aspects of design for recovery, that must be taken into consideration at the early design stage. Okay, I remember that question about where to start. So when you talk about where to start, it has to start from the beginning of life, yeah, because a lot of decisions that you make during the design stage, the BOL, yeah, has a lot of impact to the other life stages of the product later on. For example, design for X, it is something that you decide during parametric design stage, yeah, or the configuration design stage. So all these are at the design stage to make sure that your product is durable. Yeah, durable means it is tahan lasa, it is tahan, yeah, ketahanannya tinggi. Okay, because when it is durable, then it can have a longer life, yeah, which is actually the tenets of circular economy, yeah. And then modularity, as opposed to integral architecture. When a product is modular, meaning it is one component with one function, yeah. So when there is a problem with that function, you can just replace that module or that component. This is going to be different, yeah, if it is of integral architecture. Integral architecture is one component will have many functions. It delivers many functions. So there's a lot of interaction of energy, information, and signal in that one component because there are many functions there. Yeah. So in terms of maintenance, replacement, it is easier for you to focus on modular design. Yeah, that is the trend now for ease of maintenance or ease of replacement. Yeah. But there is also a setback of modularity. Yeah, not all design will is good using modularity. Yeah, some products may need to be designed for purpose of integral architecture. Yeah, especially when you want a product which is a compact design, for example. Products with a compact design, they have problems with space, with volume. Yeah? So you cannot have many components because the more components you have, the bigger is the product. Yeah? So sometimes when there is a requirement for a compact design, like it or not, you have to use integral architecture. Yeah, so in terms of recovery and so on, it is slightly more challenging. Yeah? Because there are so many functions in that component. If you want to replace one function, you have to replace the whole system, yeah, or subsystem. Okay, another aspect of design that you have to consider is of disassembly and reassembly. Yeah, this will actually require you to look at how products are assembled and how they can be reassembled easily after that. Yeah, because if you talk about remanufacturing for multiple life cycle, you need to reassemble the component again. Reassembly of old parts as well as new parts, because there are parts that are worn out, yeah, that cannot be reused again. So you have to replace them. You have to discard and use new component. So a remanufactured component will have a combination of new parts and old parts or reused parts. Yeah? And you need to reassemble them and you need to test them again. Yeah. Normally in automotive parts like brake caliper, for example, parts that can be reused, we call it core. Core, yes, the core, C-O-R-E, core. In Bahasa, we call it teras. Yeah, core or teras. Yeah, this core is normally the part of the product that can be reused many times because they are not so exposed to damage. Yeah, or maybe because they are designed for durability, yeah, in the first place. Accessibility meaning that you can access the component or the part that you want to replace or repair. Yeah.
Excuse me,
Keboleh
Professor.
capaian. Okay.
Yeah. Professor, can you hear my
Yes.
voice?
Yes.
Can you reshare the PowerPoint slide again because we couldn't see it right now?
Oh, I see.
Yeah. Sorry.
Oh, okay.
Yeah.
I will share that again, yeah?
Yeah, thank you. I'm sorry for the.
It's okay. Let me check. Share. Okay. This one. Can you see it now?
Yes, but it still haven't been, how to say that?
Okay.
Slideshow, yeah. Thank you, Professor.
Okay. All right. So I mentioned about durability just now. The more durable your component, the better it is in terms of recovery. Modularity is about product architecture. Yeah. The trend now is going towards modular design as opposed to integral design, but not all design can be developed based on modular architecture. There are some design requirements that you have to comply. For example, if you want a product to be compact, so meaning you have limitations in terms of space. So you cannot actually have all your components to be modular, because modularity means one component, one function. So you will have many components. Yeah, if there is a requirement for compact design, for example, then you may have to choose integral architecture. Yeah, ease of disassembly and reassembly. It is very important because the components, if you want to do remanufacture, they need to be reassembled again, reassembly of new parts and old parts. Therefore, it is very important consideration on ease of reassembly them together again, yeah, after restoration. It is very important. Accessibility is ability to access component, yeah, parts, for example, if you want to replace them, yeah, if you want to repair them. Yeah, so accessibility, kebolehcapaian is one requirement for multiple life cycle. Simplicity, yeah, a simple design, easy for you to disassemble. Parts and component are readily available. Yeah, for example, utilization of standard parts, screws, for example. Yeah, and ease of maintenance. Maintenance play a very important role in extending the life of the product. Yeah, because product life cycle extension will require maintenance, servicing. Yeah, that will require design for X. On the X is a maintenance and servicing, DFX. Yeah. Okay. I just put these pictures here. Yeah, a collection of some from Malaysia and some from outside. Yeah. You can see some computers being disposed, being thrown just like that. Yeah. Bottles, and then automotives being left by the roadside. Yeah. There are many in Malaysia. This has been a very critical issue in Malaysia. The abandoned vehicles are left by the roadside. Yeah. And also this can also happen in the marine industry. Yeah. Okay, maybe I can just mention a few things about plastic bottles. Yeah. Plastic bottles are the one, the picture on at the bottom left. Yeah. It is one of the highest quantity plastic bottles that be recovered in the sea, near ocean in Malaysia, and some companies are doing their corporate social responsibility. Yeah, they actually collect all this ocean plastic and they develop into recycle and make it into products. Products. I don't remember exactly what type of product, but this company they collect all this plastic near the ocean, near seasides, and they recycle them. And the one in the middle bottom, abandoned vehicle, this is a big issue in Malaysia. I think a report in 2018 reported that throughout Malaysia, there are about, the whole of Malaysia, there are about, I think about 80,000 or 60,000 abandoned vehicle in Malaysia, and it is a big issue, a big headache to the government, because if they were to tow this car, yeah, and keep them in their depot, it will be very costly. Yeah, inventory, in terms of inventory, it is very costly. But if they leave it outside, it is polluting the environment. Chemicals or engines, oil, for example, will seep through the earth, yeah, and seep through earth water, for example. But there are issues in Malaysia, like the perbandaran, or the municipality, yeah. For example, Majlis Perbandaran Kajang, for example, yeah, they cannot simply tow this car away because this car may have not been deregistered. It may be still owned by someone. So they cannot simply sort of tow this car and send it for recycling at automotive centers, recycling centers. It may seem strange, yeah, but the government is now working very hard to have this deregistration system and put on some sort of guidelines. If you leave your car like 6 months by the roadside without a road tax, for example, then we can actually tow your car, something like that. They are working towards that now. Yeah, it looks like funny, these things, but it is this arrangement under different ministry, Ministry of Transport, and part of the handling is under Department of Environment. Part of it is controlled by the local municipal, so things get complicated because of different ministries handling different, having different purview or different responsibility for this abandoned vehicle. Yeah, so it is a big headache now, and there has been meetings and so on at the ministry level to come up with a centralized deregistration system. Yeah, and then in the marine industry, it so happened that I actually studied the implementation of remanufacturing in the marine industry. Marine is one of the transportation mode that has the least activity in terms of remanufacturing, because it is, yes, difficult to implement. You can remanufacture their engines, for example, diesel engines, but other parts of the marine is not easy, yeah, like automotive or aircraft, or the aerospace, because ships, they are used for many years. It can be up to 20 to 25 years. Yeah, and these ships are sort of exposed to very harsh environment, salt water, rain, yeah, and so on. So it is very difficult to do remanufacturing. So most of the activities for recovery of the marine is for recycling. Yeah, and in the past, these ships have been sent to third world countries, yeah, to be recycled, and there's a lot of issues, yeah, like pollution, death, yeah, to workers, and so on. And now they have come up with a convention, yeah, that I do not know in detail, yeah, now, but at one point it was the responsibility of the manufacturer sort of to recall, yeah, their ships or boats, yeah, and to treat them as an end-of-life product or system in a safe manner. In the past, they sent to India, Bangladesh, to do recycling, and there's a lot of health as well as environmental issues, yeah, in those countries due to the recycling of ships. Okay, I think I have mentioned about remanufacturing. Yeah, as I mentioned just now, it is one of the most value-added strategy, yeah, for multiple life cycle, because you take back the component as is, yeah, after you repair, you restore, and you use it for the same function and performance. Yeah, as opposed to recycling, you do some processing, you melt them, for example, metal, that will require a lot of consumption of energy, yeah, and you turn it into something else, not for the same function, yeah. But remanufacturing, it is used for the same function because you bring it to the level of the similar specification, yeah. Okay, this is just a diagrammatic representation of the remanufacturing process, yeah. It details out the activity, yeah. It requires disassembly, yeah, sorting. You have to check which component can still be repaired, which one cannot be repaired and need to be replaced, yeah. And then you do cleaning, inspection, restoration, reassembly, testing, yeah. And at the end of the testing, you have to give a warranty, yeah. Some companies in Malaysia give a warranty of about 6 months, yeah. Some can afford to give 1 year warranty for their alternator and starter, yeah. Why is it more sustainable compared to recycling? Because remanufacturing does not involve a major process, yeah, like melting, where smelters used to melt metals, for example, yeah, or you need to reprocess plastic pallets, yeah. That is for recycling. For remanufacturing, you do repair and restoration, yeah. But remanufacturing will require skilled laborers, yeah? Very skilled people to repair and bring the component back to its original specification, yeah? Product upgrade, as I mentioned just now, is also one strategy for product extension of product life cycle, yeah? It is rather more challenging actually to do upgrades, to design product for purpose of upgrade, because you need an upgrade plan. You know what to upgrade, how it can be upgraded, yeah. What you can you need to focus the technology, yeah, in the future, what is necessary for that kind of product, for example, yeah. Maintenance, as I mentioned just now, yeah, we do preventive maintenance or predictive maintenance among the strategies, yeah, to extend the useful life of a product, yeah. So with that, you improve the reliability or the usage of the product in a much better way, yeah. So the question is, what do we do, yeah? So during the design stage, you design the product for ease of maintenance, yeah. Things like accessibility to parts and component that needs replacement, easy to disassemble and reassemble, yeah. To make sure that the parts use standard components, standard screws, for example, so that when you do maintenance, you can easily purchase these standard parts and component cheaper, yeah, because you can buy them as standard components and you can buy them in bulk, yeah. Okay, so these are some of the guidelines in design for maintenance. There are some, to me, like logic thinking, you know. When you read these guidelines, you think that, yeah, I know that, yeah, true. That affects how it should be designed. But sometimes when you design a product, you may overlook the simple or logic guidelines, yeah. Sometimes designers are excited, yeah, about their product, yeah. They may overlook this kind of requirements. Okay, recycle, you can recycle, recover material. That includes newspapers, magazines, mixed paper, cardboard, yeah. You can also recycle glass, yeah. Rigid plastic bottles, products, yeah, metal containers, tin, aluminium, steel can. They are very expensive now, yeah, if you can recycle metals, yeah. And then food waste, yeah. I bet there are companies that take all this food waste and change them into fuel sort of for burning, yeah. So they process all this food waste and they turn it into fuel, yeah? What about water? Water can be recycled, yes. For example, in the industry, if you have waste water, collect this wastewater, and we call it gray water, yeah. You can use it again for other applications which do not require high quality water, yeah. For example, in fact, in some areas, they use or industry, they will collect all this wastewater, as long as it is not containing E. coli or fecal or something like that, yeah, you can use it for washing and so on. So you will use less water, yeah? As long as it is not for the consumption of high quality water, this water can be sort of captured and used again. You can collect wastewater. You can also collect rainwater. Yeah, you can harvest rainwater, for example. Okay, these are just some guidelines on recycling. Yeah, I think I got this from the internet. Actually, examples on how Adidas actually recycle plastic shoes. Yeah, how they use they manufacture jackets from plastic jackets. Patagonia. That's a brand or company name. And then toothbrush recycling. Yeah. So there's a lot of as long as the plastic is recyclable, yeah, then there's a lot of industry, especially overseas. Yeah, they are more creative and innovative in looking at how they can actually use recycled plastics. Plastics is one of the top waste that you can find in oceans. And also cigarette butts. Don't be surprised. Cigarette butts also. There's a lot you can find in our oceans. I think in Malaysia, yeah, there is a statistic. I do not know other countries, but in Malaysia, cigarette butts, plastic bottles, plastic bags. Yeah, all these are. It has like been affecting the ocean, and some universities are doing research on this, and they find microplastics in the stomach of fish, fishes in the sea, even in Malaysia. These are just some case examples of remanufacturing. They are very successful in this. Renault, a French automotive manufacturer, they actually remanufacture water pumps to engine. They sell it 50 to 70% of the original price. These are just some of their activities. They share a lot of information on the internet. They may not be going into very detail, but they share some of their initiatives in remanufacturing. If you are subscribing, if you subscribe to Remanufacturing Industry Council, from time to time they will have seminar, seminar sharing industry, sharing of how they actually implement remanufacturing, how it is implemented in the electrical industry, electrical electronics industry. It is free, then you don't have to pay. You just subscribe, you just search Remanufacturing Council, Design Council, and then you you can subscribe, and they will let you know from time to time when they have seminars, webinars. But of course, the webinar is sometimes the timing, sometimes until starting at 10 o'clock and finishing at 2, 3 in the morning, because of the time difference. But it is worth looking at how they implement it, and they spend a lot on machines and training their workers. When you say training workers, is very important, because when the component comes to your company, if you are a remanufacturer, you have to inspect the component. You have to decide whether the component is still worth remanufacturing, or the component cannot be remanufactured because there's a big crack, for example, a damage, a severe damage. It cannot be remanufactured. It has to be recycled. So making that kind of decision, and also how to repair, you will require some skills, some important skills, exposure to remanufacturing. Okay. This is also Caterpillar. Caterpillar also shares a lot of information on their website. This is about gearbox, drivetrain. Please go to their website and see how they actually conduct remanufacturing. Also, some companies like Photocopier. Photocopier is very possible to do remanufacturing, because it is not a safety related industry like automotive or aircraft, yeah, but they do a lot of remanufacturing. Yeah. Dr. May, you please stop me when the time comes, yeah?
It's actually 11:50, Professor, but I think everyone don't mind if you continue with the webinar.
Okay.
Yeah.
I'll go very quickly.
Sure.
Yeah, because maybe there are a few slides of the same topic, then maybe I can just go through it very quickly. Yeah.
Sure.
Okay. I want to highlight some of the challenges that we have when you talk about remanufacturing and so on. Yeah. Poor design of products that do not support recovery. That is one thing. And inconsistent supply of course. Yeah, sometimes companies would have problem getting supply. Yeah. And then lack of knowledge on remanufacturing, yeah, and lack of consumer appreciation. These are some of the important or significant challenges when we want to implement remanufacturing. It so happened that now I am actually leading a project. Yeah, it is a grant given by the Ministry of Education Malaysia. UKM is looking at poor design issues. Yeah. And then UTM is looking at inconsistent supply of course. UTM is University Technology Malaysia, the public university at the south of Malaysia. Yeah. And then UTM, University Technical Malaysia Melaka, our partner, is looking at the use of enabling technology, the application of enabling technology for remanufacturing. They are looking at possibility of how best to utilize additive manufacturing to do repair and restoration. That work has also been done in UKM, but we have to sort of divide the work. Yeah, so we assign that to UTM, and the project is ongoing now, and it's supposed to end by end of this year. Yeah, so it is a study done by 3 universities trying to look at significant problems or challenges in implementing remanufacturing. We have national remanufacturing policy, we have national automotive policy, we have standards on remanufacturing, but companies will still have problems to implement because of a shortage of supply, because there's also problems in designing in remanufacturing because products are not designed for that purpose. If we do remanufacturing, most of the time it is damaged. Therefore, we have to recycle instead of remanufacture. Yeah, and also because we are talking about IR 4.0 enabling technology. Yeah, how do we actually deploy this kind of technology to support remanufacturing and recovery of component? Yeah, okay, just for your information on that. So enabling technology is maybe I can just highlight the importance or the need to share information, data, yeah, from BOL to EOL, yeah. So software like product lifecycle management, PLM, yeah, if you look at the architecture or written reports on PLM is should be able to sort of capture and enable information and knowledge to be shared throughout the product lifecycle, because PLM is a very design-centric tool. Yeah, okay. I think you're also familiar with PLM. Yeah, that is one of the software that a design-centric software that can capture knowledge and information. Yeah, about product throughout its life cycle. Okay, these are some of the applications of IoT, big data, and data analytics. Yeah, on how it can support the development of sustainable products. Yeah, okay. Additive manufacturing, in the past, it is used to fabricate parts, yeah, for part replacement, a quick way of getting parts for replacement. But nowadays, the trend is looking at how additive manufacturing can be used for repair and restoration. Yeah? if people look at adding, for example, if there is a crack on a component and that component is it's a hairline crack, and that component can still be remanufactured, then we can, the traditional way is using welding or adding material layer by layer on that crack surface, and then you test to see whether it is able to perform. But now the trend is people are looking at possibility of how can we use additive manufacturing to use to repair and restore component. Yeah, but of course these additive manufacturing machines are expensive. Yeah, so how do we justify the good things about additive manufacturing in terms of repair and restoration? So studies are ongoing on this. RFID, it is for locating and tracking. Okay, RFID is not just in manufacturing, in the BOL, but it can also be used during the MOL and also the EOL, because it is able to sort of capture some of the history or of the parts and component, where they go, how they are being treated during the useful life. For example, we can actually use RFID to do that. Okay, this is about capturing product life data. I think this can be represented in sort of the product life cycle management thinking. Okay. And then these are some industry practices in repair and maintenance. They use satellites to actually detect the condition or to locate where their cars are, so that they can actually recall them and do repair and maintenance, for example. These are some of the multiple life cycle challenges I put on the left. What are the strategies that we can take to overcome the issues, and also the enabling technology that can be used. For example, okay, the last one, the simple one, unavailability of parts for replacement due to product obsolescence. Because when you do remanufacture of product, it's after a few years. By the time the product reaches end of life, the parts and component may not be already available in the market. So to ensure parts availability on demand, we can use additive manufacturing. This enabling technology can help you to fabricate parts and components which are not available in the market already. And also AI techniques can be used for machine learning in AI, for example. Okay. This is just some research ongoing, and some have already completed. They use analytical hierarchy process for designing multiple life cycle product, because a lot of decision has to be made. How this is multi-criteria decision making process. Okay. And then design of upgrade of brake caliper. A student actually attempted to design for upgrade for brake caliper. This is actually a PhD work and has been completed already. The need for upgrade plan is very important. Okay. This is to show some of the work about designing for restoration using additive manufacturing. So during the process, students will study what are the additive manufacturing technology good for repair. We have direct energy deposition, for example, laser cladding. All those are advanced 3D printers, but we don't have that kind of machine in Malaysia. It is very expensive. It costs millions. University can afford to buy. Okay, and even the industry may have, but maybe not the direct energy deposition technology. And direct energy deposition is one of the best so far, laser cladding and cold spray, to conduct repair and restoration. Some other additive manufacturing technology, like there's direct laser sintering machine, powder bed fusion technology, basically, can be used to repair component, for example, doing something similar like welding, adding material layer by layer. But there needs to be some modification to the platform or some holder necessary for parts and component that you want to repair. So it needs some modification to the hardware. Yeah? Okay, this is just to show some ongoing work. Okay, how do we move forward? We capture and share data, information, and knowledge effectively. Yeah. Acquire knowledge and skills to deploy the appropriate enabling technology. There are tasks which can be supported by enabling technology. Yeah. For example, the PLM, yeah, product lifecycle management, CAD/CAM, CAE software. Yeah. These are mode of communication actually between designers and manufacturers. Yeah. And then enhance collaboration throughout the product life cycle to facilitate data and knowledge sharing. Yeah, because sometimes we are expert in design, but we are not expert in manufacturing. Or I have the facilities for manufacturing and I have the resources, but I'm quite poor in design ideas, how to improve my design for recovery, for example. Then it is very important that you have a proper collaboration and work together. Yeah, because if you have to acquire the knowledge from scratch, then it will take a much longer time. Yeah. Ascertain intellectual property rights, yeah, to ease flow of information among interested parties. Yeah, this is one of the issue, for example, in remanufacturing. Yeah, for example, if I have an Mercedes-Benz engine, yeah, to remanufacture, and then I do modification to the engine, and I allowed, yeah, to actually do that modification because the machine is owned by Mercedes-Benz, for example. Yeah, how is the IP arrangement like? Okay, and also, most importantly, enhance creativity and innovation in design and manufacturing so as to move forward in the circular economy. If you look at the typical product development stages, normally when the product reaches end of life, then the information has not, we stop at sharing of information. Yeah, and by right, it must be enhanced. Yeah, sharing has to be enhanced to facilitate feedback of data, information and knowledge, yeah, from the BOL, yeah, and also the EOL stage back to the designer. Okay, so that they can actually improve their design. Okay, there's a lot of tools that can help you to improve your design. You do failure mode and effect analysis. You can do fault tree analysis. You can do lab testing, for example. Yeah, but you need, as a designer, you need feedback from all these stages of the product life cycle. Yeah, so it is very important. In the past, we may not be concerned because products are for single use only. Yeah, but for now, we have to think of possibility that the product be used for multiple life cycles. Okay, conclusion is sustainability has to be designed into products. It has to be worked upon, yeah, from the early stage of the design. And then capturing and dissemination of data and knowledge from design, manufacturing, and end of life, and the whole supply chain is crucial to support development of sustainable products. Yeah. Development of environmentally conscious products must equally address socio-economic aspects, namely all three pillars of sustainable development. There are three items in the sustainable development. It's not just environment. There is a social aspect and there is the economic aspect. When we want to push industry or the community to support environmentally conscious initiatives, it has to address all this. Company must also see the returns, yeah, of their investment. So that's why the government play a very important role at the initial stage, yeah, to sort of work together with the industry. It may be in the form of incentives, for example, yeah, support, training, and so on, yeah, in order for this to happen. Okay, I think that's the last of my slide. The next is the quiz, I think, Dr. May. do we want to proceed with quiz?
I think we can directly to question and answer. Is that okay, Professor? Because
Yeah, okay.
it's already past the time. Yeah.
Okay.
it's really interesting. So I think there are already some questions that I haven't.
All right. Okay, good,
Yeah.
good. Yeah,
And
I will
for
try
those
my
who
best to
still,
answer.
yeah, for those for the participant that wants to ask the question, you can raise your hand or either you can chat in the chat box. Okay, the question is from Intan from UPN Veteran Yogyakarta. How do we convince manufacturers or companies that circular economy is important and good for their business? So we already know there are some pushing factor, the SDGs, the ESG from the government, but how, aside from the pushing factor, how do we convince manufacturers or companies?
Okay. Okay, this is a good question from you. It has to, the government and all stakeholders can actually sort of, to a certain extent, give their support. Yeah, it could be monetary support, it could be incentives, it could be sharing of knowledge, from the university, for example. But the most important thing is the initiative of the industry himself or herself, to start with these green practices, developing sustainable products, because the initiative and the innovation will come from the industry themselves. Yeah, and normally the government can assist, can support, but the awareness and the knowledge has to be acquired by the industry in order for them to move forward. It is very important to have that awareness. Yeah. So if the government has some training programs or awareness program, please, the industry, I think, motivate the industry to, as university, and you are working with the industry, motivate them to actually join these initiatives, because it has to come from them. Okay.
Yeah, thank you, Professor. Let me ask the questioner. Is it answer your question, Mbak Intan Istiqomah?
Yes, thank you, Professor Zuraida.
Okay.
I actually still have question.
Okay, yes, please go ahead.
So, because we know that there are three life cycle, the BOL, MOL, and EOL, and I noticed that during the middle of life we have a monitoring type of how to say, that's the time where the industry do the monitoring. They can do it by monitoring their customer, but if the product itself, I believe if product itself is high value product, then probably the customer will be willing to give their, let's say, complaints or their feedback. But how if we deal with kind of like low value products, not too expensive? How can the company can monitor the
Yes, thank you, Dr. May. Yes, products can be divided into products that are of high value and it is worth recovery, or products that are not of high value, that you would end up sometimes just recycling them or disposing them, but in a safe way. So as a manufacturer, it is by right we should have the initiative to work with our consumers and at the middle of life, for us to understand better the product, how we can improve the product. It's not just getting customer complaint, but that kind of information can help us to improve our product better, improve our material, improve the processing. And it is very important that we have the conscious mind of or the design thinking mind, as I mentioned just now, so that we can improve our product from time to time. If the product is of low value and it cannot be reused, then we have to choose the option of recycling or disposal, but make sure it is in a very ethical manner on how it is actually disposed.
My next question.
Okay.
So if I'll ask the participant. If you have any questions, but you're too shy to ask, you can just write it in the chat box. It's okay. And then I will ask Professor Zuraida. And my question is that regarding the upgrade or the refit, I think you used the term refit too. You mentioned that it's quite difficult because we need to do the forecasting, I think, technology forecasting design. So how can a manufacturer or industry do the forecasting technology or forecasting design?
Okay. When we want our product to be upgraded at a certain time, for example, in 5 years or 8 years, there need to be an upgrade plan. The upgrade plan will require not just when to upgrade, but also what aspect of the product can be upgraded. And it is very important that the industry knows the trend in the technology. For example, they know, for example, if I'm designing a product, designing a engine, for example, I'm using a ICE, internal combustion engine, for example, and then I know that the industry is moving towards the use of EV, for example, or hybrid, So how do I actually plan? Do I just straight away eliminate my ICE engines, or how do I actually upgrade my products, or maybe focus more on battery, for example, battery management system? How do I actually focus battery? Maybe ICE and hybrid is not a good example. If you're talking about battery, battery management system, after 5 years, for example, how can I add a module, for example, in my battery, that will actually support the use of EV, in the future, if there is, for example, an advanced application of EV, who knows, So which part of my design can be sort of plug and play with this kind of advancement in technology? So I think those in the area or in the industry would know, what is the trend in the technology. They should be able to sort of predict and understand what's going to happen, what material is going to be used, how is the architecture like in products in the future, what is the requirement, why is it necessary to come up with modular design, for example. So those in the industry would know better the trend or the growth in technology for that matter, for that product.
Okay,
so
thank you,
there needs to be a lot of study, technology, learning of new technology, for example, aware of what is coming in the next 3 or 5 years. So and then it's a better way of upgrading. You are in a safe way, in a safe, safer, if you want to do upgrade, if you know what's coming. But some products are very stable, there's no need for upgrade. This kind of products may not require upgrade, but for advanced technology, that moves very fast, it's best if your product is related to that kind of technology. Then I think you have to really know what's coming, so that you can easily upgrade your product later on.
Okay, thank you so much, Professor. There is a question, I'm not sure whether it's related or, but I will try to ask. So from Sajid Ali, what is the main reason behind the General Motors bankruptcy? So I'm not sure.
General
Motors bankruptcy. Is it the quality or lead time or standard product?
I do not know exactly what's the problem with GM. I've not read about that, but we know that industry that are left behind are those that are not fast enough, not willing to change. Because especially in industries like that, technology changes very fast. People are using new technology, for example, from internal combustion engine to hybrid to electric EV, for example. So if you want to retain or remain with that kind of technology, then after a while, people may say that no, we're not going to change that fast. We're still using internal combustion engine, for example. Yes, but there are activities, that are looking at how fast, we can actually move towards that. So if you are still in that using that kind of technology, then we may be left behind. That's a good question. That will allow me to read about GM after this. But I notice many companies who are left behind is because they are very slow in moving or changing. The world is changing, but they are still, using their old technology for many reasons, or some other reasons which we do not know. Okay.
Okay, thank you, Professor. Is there any other question from the participant? Okay, if not, I would like to applaud Professor Zuraida and would like to convey my gratitude for today's webinar. It's really interesting, Professor. So I will try to conclude it first. So basically, to achieve the CE, the circular economy, whether it's a product or the supply chain itself, it needs the commitment of many stakeholders. It needs the commitment of resources, and starting from the BOL, the beginning of life, middle of life, until the end of life itself. And there are, aside from that, so we are not only thinking about the environmental aspect, but also we need to think about the social aspect and economic aspect, and how the governance can help us to achieve that. And there are many strategies that can be done to achieve the circular economy, and how it can help to achieve the sustainability. Okay, there is a question from the participant. Will it be possible to get the material from Professor Zuraida?
Yes.
Okay.
I can share this. I will email it to Dr. May. Yeah.
Okay, so all the participants that already fill the attendance list will be sent the material from Professor Zuraida.
Yeah.
Okay. Again, thank you so much, Professor Zuraida, for coming to today's webinar. Yeah, and we will meet again tomorrow morning.
Okay.
At the same time.
Inshallah, yes.
Inshallah. Okay, I will return this back to Kinan as the MC for today's webinar. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
All right, thank you so much, Professor Zuraida, and also Dr. May, for your beautiful material. Alhamdulillah, we have come in the end of today's webinar. I hope that you, ladies and gentlemen, can get benefits, experience, and understanding of these webinars. And I am the master of ceremony this morning. Apologize if there are any mistakes. And thank you very much once again for your joining today's webinar and your nice attention. Don't forget to join our second session of Sustainable Products and Supply Chain for the Circular Economy webinar on 9 August 2022. And for more information, you can kindly reach our social media at industrial.ipuii on Instagram. And wal akhirul kalam, undur mangkola wala tandur mangkola, usikum wa nafsi bitaqallah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Master Ceremony. Thank you, Dr. May, and everyone.
Thank you, Professor.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Welcome to Yogyakarta. Welcome to Universitas Islam Indonesia, a city with thousands of stories, a university with precious stories, a city with captivating cultures, a university with wisdom and values. This is the place where all dreams and hope are conquered with the basis of Islamic values, valuable knowledge, science, independency, maturity, and friendliness towards its objection to perfection, being the part of global community. Welcome to International Program, Department of Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia. International Program Undergraduate Program was established in 1999 under Department of Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia as responsive response for challenging global competition. A place with international exposure, distinguished lecturers, and sophisticated learning atmosphere. A place where ideas and thoughts are actualized to tremendous design, outstanding research, and remarkable products as its contribution to environment and global community. This study program is accredited A from the National Accreditation Board and AUNQA certified for its curriculum. Teaching and learning processes, research and community service have been equipped with various adequate facilities and laboratories. There are 6 laboratories: Integrated Manufacturing System Laboratory, Organizational Innovation and Development Laboratory, Enterprise Resource Planning Laboratory, Work System Design and Ergonomics Laboratory, Data Mining Laboratory, Modeling and Industrial Simulation Laboratory. These laboratories provide students with skills and specialties in product planning and control, as well as production floor management, designing, producing, assembling products, calculating inventory and the number of workers, scheduling, implementing product control, and others. This laboratory focuses on areas of industrial systems innovation and management, such as corporate design analysis, organizational development, marketing system design, and business feasibility study. This laboratory provides skills and specialties about enterprise resource planning. The learning process is supported by the SAP system and has been a part of the SAP University Alliance since 2005. The SAP University Alliance provides opportunities for students to access learning materials, participate in SAP academic forums, and certification of participation that is recognized nationally and internationally. This laboratory provides skills and specialization in the application of work system design application concepts in order to achieve a certain level of productivity, ergonomics, and aspects that influence it, especially psychological and environmental aspects. The laboratory focuses on analyzing and designing a work system and/or work tool to be ergonomic, safe, comfortable, and healthy. This laboratory provides skills on the use of various methods of multiple criteria decision-making, data mining, and statistics to solve problems in the industrial world. Modeling and Industrial Simulation Laboratory provides skills and understanding of the definition of models, types of models, to create simulation based on real systems. The International Program of Industrial Engineering has maintained and expanded the international collaboration as the effort for the global acknowledgement to provide students with global experiences, exposures, and mobility. The program has also worked with big companies in Indonesia and abroad. Students are also accommodated with international certification to develop student skills to achieve designated expertise. International program exposes students with international experience, culture, and environment as a part of global community. As a sustained effort to sharpen students' capability in certain expertise, the internship is represented as the program that could fulfill the curiosity of a real-life working environment. Community of international students is established to encourage students with soft skills, organization, and teamwork activities. All activities in the international program are beautifully framed under the noble Islamic values with the ultimate guidance of Al-Quran and Hadith.
International Program Industrial Engineering.
Be smart,
be agile,
and be global.